So applying it, we are solving a logarithm equation by using the properties. And so basically it gives us this, the loudness of sound L in decibels is defined as L equals 10 times the log base 10 of R, where R is the relative intensity of a sound. So a choir director wants to determine how many members could sing while maintaining a safe level of sound about 80 decibels. So we want our level loudness L to be 80 decibels. So there's L. And if one person has a relative intensity rate, so one person has a relative intensity rate of 10.6, we want to find out how many can it be, right? How many people could sing with the relative intensity to achieve a loudness of 80 decibels. Okay, so basically we want to get R by itself because we know the L, right, is 80. We want the loudness to be 80. So basically we can take this equation and just solve it for R. So if I do that, well, to get rid of multiplication, I have to divide by 10 first. Oops, 10, not 18, geez, is 8. And so that would be log base 10 of R. And then to solve a logarithm, we just switch it to exponential form, right? So this just switches to 10 is your base. These are never on the same side, right? And then my exponent is the answer, 8. Okay, and now we said we wanted our R to be 10.6 per person, right? If one person, so that would be however many people I have, right? The intense rate would be 10 raised to the 6. So now I have R is equal to 10 raised to the 8, but we want R to be for every person, so we can let X be the number of people times 10 raised to the 6. That would be the loudness, or that would be the relative intensity per person, right? It's 10 raised to the 6. So depending on how many people, and we want that to reach 10/8. So if we just divide, we can solve by x. And remember, when we divide by the same base, we subtract exponents. So x would equal 8 minus 6. So that'd be 10 to the 2. And that would be 100. And so that's how many people that we can have that would reach a level decibels of 80.